All right, welcome to the History of Diving Museum, our Immerse Yourself series. We'd like to thank our sponsors, the Vitale family, who are on the board at the History of Diving Museum and have been involved with us from the very beginning. We appreciate our sponsors helping to put this program on. It's on the third Wednesday of every month, hosted at the History of Diving Museum as well as online. So for those of you that will be tuning in for next month, we will have Amanda Carter, who is the curator for the Texas Parks. We have a lot of Texas going on this month and next month. The Texas Parks and Wildlife Department, their historical site, the Battleship Texas. It was commissioned in 1914. It's the last battleship that served in World War I and World War II, and it became the first floating museum. So we're going to learn about that whole process. There's a lot of things going on with artificial reefing, but in this case, they're preserving the battleship for people to be able to walk through. And a lot of things are happening at the History of Diving Museum, so be sure to check out our website. On Sunday, we've got a speaker that will be on site, Dr. David Karash, who's going to be talking about diving injuries and what every diver needs to know. That will be in person as well as, again, on Zoom. So that brings everybody up to date. But what we have tonight, so thank you, we have Kris Benson from NOAA. He's currently working out of the Galveston office. He'll be telling us more about the Deepwater Horizon and some deep water restoration. We know that a lot of things are going on in the Keys, but this will give us a feel for what they know and what they can do for their deeper habitat. So Kris, we thank you for being with us tonight, and we look forward to your presentation. If anybody has questions, go ahead and put them in the chat. And Julia, our community relations specialist, is going to be moderating, and she's going to be getting those ready for Kris. So go ahead and put those in there. If you're watching online with more, a couple people in your family, let us know how many are there and how many and where you're from, so we can see all the people around the world that are watching tonight. And Kris, take it away. Tell us more about the deep ocean.
Okay, absolutely. I just want to make sure you guys are seeing the screen, my slide deck here at full screen. And I notice I'm getting a message that there are several folks in the waiting room. So I want to make sure anyone waiting to join is able to do that. But I'll go ahead and get started. So yeah, again, my name's Kristopher Benson. I work with NOAA's Restoration Center. And I'm located in Galveston, Texas, and really appreciate the opportunity to speak to you all tonight. I'm going to talk to you about some of the restoration work that is proceeding in the aftermath of the Deepwater Horizon oil spill, but I'll first give you a little bit of background about the spill itself and the process that we used to get to be able to do restoration work. So it's hard to believe it's been over a decade now since the spill. And here are just a few sort of overview stats about it. It was April of 2010, floating offshore drilling unit exploded and sank to the bottom after 11 days of a fire, and 11 people were killed in the event. I'm sorry, it was only 36 hours, I think, before the thing sank, but 11 people were killed in the event, and 134 million gallons of oil spilled over about a 3-month period after the sinking. It was the largest offshore oil spill in U.S. history and had a dramatic effect in the offshore and coastal environment. And I'll get to some of those details here in just a moment. So specifically about the habitats that I'll be talking about, the restoration work for mesophotic and deep benthic communities, we we quantified injury to these habitats in an area of over 2,000 square kilometers around the wellhead. And there was an additional major loss of corals and fish that was documented specifically in an area around the Pinnacles, which is a offshore reef habitat on the continental shelf edge south of Mississippi and Alabama. It was about 10 square kilometers of major damage to corals and fish documented there. There was also additional oil exposure. This wasn't quantified injury in terms of critters, impaired or dead, but exposure to hydrocarbons, which can cause impairment over an additional 7,500 to 12,000 square kilometers of benthic habitats, and those extended from the wellhead up the continental slope and onto the continental shelf. There were many other documented injuries in the coastal areas along Mississippi, Alabama, Louisiana, Florida, and Texas. 1,300 miles of shoreline oiling documented. The surface slick from the oil spill was the size of the state of Virginia, and obviously, with flocculent materials that absorb sediment and so forth and sink to the bottom, that hydrocarbon also could affect bottom habitats over a much larger area. So in order to document that injury, we go through a legal process called the Natural Resources Damage Assessment. The point of this process is compensatory. It's not punitive. It's essentially the polluter pays for the damage that was done, and the purpose is to make the public whole and the environment whole for the injuries that were caused. And in this case, we had federal trustees from 4 federal agencies involved, and trustee agencies from each of the 5 Gulf states involved in that damage assessment. At the end of the day, the settlement that resulted from that civil case was $8.8 billion for 13 different restoration types, ranging from coastal habitats, as I said, to the bottom of the deep ocean, and about $250 million of that was dedicated to restoring these mesophotic and deep benthic communities. And this whole process is, just for a little background context, this whole process is really specified by the Oil Pollution Act, which was enacted after the Exxon Valdez oil spill in the early 90s. Okay, so after the settlement for the natural resource damage assessment happened in 2016, the trustees developed a programmatic damage assessment and restoration plan, and called out in that plan some important considerations relating to mesophotic and deep benthic communities, and this really resulted in an approach to restoration that looks very different from typical natural resource damage assessment restoration projects. Because we know so little about these habitats, even to the extent of where they are on the planet, the sort of food web connectivity among the organisms that live in them, their reproductive modes, and genetic connectivity among populations, the difficulty even in getting to them. So this is all in remote areas that are very difficult to access. We really took the approach of a phased implementation plan that allows for a lot of data collection, much more so than in a normal NERDA restoration project. So a lot of science to inform restoration, inform where we're uncertain about how to proceed, and inform our decision making. And so the most direct approaches to restoration in these habitats are to place hard ground substrates and transplant corals, and then secondly, to protect and manage mesophotic and deep benthic coral communities. But both of these things really require a tremendous amount of science to inform these activities. So that was how the restoration was sort of spelled out at the programmatic level in 2016, 17, and then in well, actually, let me continue a bit with this programmatic level. So the goals again for this restoration type are restoring invertebrate and fish abundance and biomass, focusing on these deep water coral sites and other hard ground areas that are real priorities and sort of biological hotspots, trying to support connectivity between coastal habitats and offshore. Secondly, actively managing these habitats, protecting against threats, providing a framework for monitoring and education and outreach. And finally, improving understanding. And really, this improving understanding goal is key in this restoration type because, again, we just have so many gaps in our knowledge about these habitats. So a large part of the portfolio projects that I'm going to tell you about next is really science, again, to inform our restoration work. So following on that programmatic plan in 2019, we published a more detailed plan focused on 4 of the restoration types that were included in the programmatic plan. And of those, so the intent here for mesophotic and deep benthic communities projects was, again, supporting the implementation of them by monitoring and scientific support to inform our understanding of community characteristics, trophic structures, linkages, food web dynamics, habitat distribution. Ultimately, though the NERDA trustees are not regulatory in nature, we would not be the entity to use information that we might produce to protect these habitats. We can provide that information to the entities that would, and those might be entities like the National Marine Sanctuaries Program, or like the Gulf of Mexico Fisheries Management Council, or the Bureau of Ocean Energy Management. These are organizations that, as part of their mandates, do in fact, through regulatory mechanisms, protect and manage these habitats. These 4 projects that were selected in this plan in 2019 allocated about $126 million out of that 273 that I described were dedicated to this restoration type. And these projects are going to be carried out. They've been in process in sort of planning phase for about 2 years. We're just finishing our first year of field work, which I'll describe in a moment. And they'll be going on for the next 5 or 6 years through about 2027, 2028. So those projects are project focused on mapping, ground truthing, and predictive habitat modeling. So this really is helping us understand where these habitats exist on the planet, and particularly in the northern Gulf of Mexico, giving us better resolution mapping and really fine scale resolution mapping to the point that we're able to characterize the existence of organisms on the seafloor, not just geologic forms. Secondly, the project called the Habitat Assessment and Evaluation Project, and this one is very focused on documenting how these communities work, trophic connectivity, the food web that they represent, the age dating and growth rates of organisms that live in them, so the life histories of these organisms, and their reproductive modes, again, genetic connectivity, etc. And that's everything from sediment in fauna to the structure forming biota on the seafloor, the corals and the sponges, up to the fish and water column invertebrates in the demersal community, just around right near the seafloor. Thirdly, we've got a sort of a pilot project really focused on developing techniques to propagate these specific corals that exist in these deep water habitats that were documented as damaged during the damage assessment. So there were about a dozen species that were documented that make up the large majority of those numbers that were counted as injured, of coral colonies that were injured. Of those, we've targeted 4 as really primary targets for this propagation technique development. And the emphasis here is on the fact that nobody's really tried to propagate these corals anywhere in the world before now. There have been a very few like lab scale pilot projects, but nothing that really attempts to scale up to the scale that we need to be at in propagating these to be commensurate with the injury that was documented. So we've got a number of corals in the mesophotic zone that are part of that priority group, and 1 species in the deep water zone that was also prioritized for this propagation work. And the requirements of this work are I think much more rigorous even than we've seen how difficult it is to restore corals in shallow water environments, and it's even that much more so in these habitats that are very difficult to even emulate in the lab, the conditions that these organisms exist in. Finally, we've got a project called the Active Management and Protection Project, and this project is really sort of 2-part focus, partially on education and outreach, and partially on threat reduction activities. And I'll get into a little more detail on each of these in just a moment. So just for context, I want to clarify what we're even talking about when we say the words mesophotic and deep benthic communities, because it's a mouthful and might not be clear to everyone. So the word mesophotic is comprised of root words that come from or sort of translate into middle light. So meso is middle and photic is light, and so this is really the zone in between about 50 meters and 300 meters. So maybe just past recreational diver depths down to about 1,000 feet. So maybe as deep as you would ever see divers going in a saturation dive context. Deep benthic, anything beyond that 300 meter zone. And as I mentioned before we got started, that really takes us down in our focal area for these projects. It takes us down to about 3,000 meters depth. And this is that area of interest for our projects. So you'll see essentially the 50-meter isobath as the northern limit, and the 27th parallel as our southern limit of our area of interest. And we know of about 50 areas within this polygon that are sort of smaller polygons shaded in pink here that are known high-value mesophotic and deep benthic community sites, but there are probably many more that we do not know even exist. And so that's a lot of the basis for our approach to including some exploration work in our mapping project in particular. Okay, so maybe for a little more detail on the mapping ground truthing predictive habitat modeling project, to better understand these communities, to inform management and resiliency, document abundance and distribution of these habitats, provide fundamental information to prioritize and support their protection and management. So these are sort of the activities within the project focused on compilations of existing information, existing data, acquisition of new data through a variety of sensors and platforms. So everything from multi-beam echo sounder surveys from ships to laser scanning and optical imaging from autonomous underwater vehicles, and probably most impressively to my mind, we're using a technology called synthetic aperture sonar from autonomous underwater vehicles, which is producing maps, bathymetry maps for us in a 3-centimeter resolution, which is really unheard of relative to any of the sort of data that's been collected previously. And you can kind of see the iterative approach that we're taking to improving on those map qualities in the image on the right-hand side of the screen, where we've got a earlier survey with a 20-meter grid cell size down to an AUV-based survey with a 1-meter grid cell size, and we learned so much more about the geoforms of the seabed with these more detailed maps. So this is very important for supporting development of habitat maps and informing the rest of our portfolio, and then also getting this information out to the public, to all of our partners and to the public generally. So the Habitat Assessment and Evaluation Project, again, informing better management and ensuring resiliency, filling critical data gaps, evaluating sites for direct restoration and protection activities, identifying ongoing impacts and assessing threats, obtaining data to quantify trends affecting these habitats, assessing our restoration activities as they're undertaken, and particularly focusing on metrics related to habitat recovery, natural mortality, growth rates, and determining baselines for health and condition to help us guide our restoration and protection activities. So again, on the coral propagation technique development project, this is getting more toward what I might characterize as our traditional model of habitat restoration. It's really on the ground. It's science still. This is a pilot project, but the ultimate objective here is propagating corals and restoring the habitat directly. Also indirectly restoring the fish and water column community that relies on that structure. So objectives here: developing methods and techniques to enhance coral recruitment and growth, recommending successful methods, and this is important, to scale up the methods that we find to be successful under a future restoration plan, because as I described, there's still a large part of the allocation of the settlement for this restoration type is yet to be committed to project work and will be in a future restoration plan. So that's where we have the opportunity to scale up these techniques that we find work, and again, directly compensating the loss of these corals and associated benthic communities. Okay, again, in the active management and protection project, actively manage these habitats, protect against threats, provide framework for monitoring, education, and outreach. But in particular, so this is sort of bifurcated, this project, between a conduit for our whole portfolio. All of these 4 projects need to get information that they are producing out to the public and out to management entities. So the education and outreach and science to management objectives here are very important in just serving as that conduit to translate and inform the public and the academic community and the management community about the work that we're doing. And then on the other side of the project is a suite of activities that are really focused on threat reduction. So things like marine debris removal, invasive species removal, oil and gas infrastructure, assessing and remediating oil and gas infrastructure that may have been abandoned in place permanently, legally, and you know, not even required permitting at the time if it was decades old, but may still present a threat today and an opportunity to reduce threats. So mooring buoy installations that might prevent boat anchor damage. You see a lot of that down in the Keys with the sanctuary there. Other commercial, recreational, and scientific activity also presents threats to these habitats and opportunities for us to sort of hone in on, can we reduce user conflicts that might be producing threats, for instance. So that's the other side of the coin, sort of the more direct on the ground restoration focus of this project. So getting back to that project schedule, I mentioned these are going to be going on through 2028. We just completed a planning phase that ran through the third quarter of this year, and you'll see that outlined here in red. We are currently working our way toward, we're in a process of evaluating our planning phase data and the information that just came out of our first field season and processing that data, evaluating it for how to adjust our project plans for next year. So we developed in the last quarter a sort of high-level annual work plan and budget. This quarter we're looking at sort of annual reporting and our adaptive management for next year. And then next quarter we'll be really nailing down the details of our field season for next summer. Spring, summer, fall really is basically March to maybe October is the best opportunity we have to do work in the field. So I mentioned we just finished that field work season in 2022, and I think some of my following slides are going to cover that activity. So out of that 2-year planning phase, we had some very important outcomes, and really this is what informed our next 5 years of work in the field. For instance, we had a mapping, ground truthing, and modeling project inventory of existing geospatial data that really helped us identify gaps that we can go fill with our field work. And we completed, with a lot of stakeholder input, a spatial prioritization exercise that helped us hone in on where to carry out our project work and what we need to be doing among our project objectives in any location that was prioritized. That's what these maps are showing you. I think we had 60 or 70 participants in this prioritization process from a wide range of stakeholder interests, and you'll see that the real priorities pop up around either the sites around the wellhead where there was documented injury, or known reference sites, the sites that are known with important mesophotic and deep benthic community habitats existing in them. Let's see. We also included a similar bibliography and data inventory for the habitat assessment and evaluation project, yielding a similar sort of gap analysis about where to go do work with that project and what to do under it. In the coral propagation technique project, we did coral collection in the field that yielded both preserved samples for genetics analysis and live samples for husbandry in 2 of 3 federal labs that we've stood up in a a network of labs that are undertaking this propagation work. We saw spawning events in both of those labs in 2021, and we actually saw that repeated in 2022. Very serendipitously, we completed these collections just ahead of when spawning happened in a field. We had some suspicion it might be timed, in concert with the spawning that we see in shallower water corals, but there's been no previous documentation of this. So this is a major finding for our project. We're learning a lot about the mode of reproduction for a couple of these species that are real priorities for us. So we also held a series of project workshops to help to learn from folks, best practices for carrying out a lot of the work that we intend to carry out over the next 5 years, and we're publishing all of that input in a series of reports that are forthcoming, along with the inventory reports. For the active management and protection project, we were a little behind the 8 ball in that project, and needed to bring on some team members to really get that work underway. So that's been done now, and I'm going to call out a couple of contacts who might be particularly interesting for you all at the museum at the end of the slide deck. And then very importantly, managing work with projects of this scale requires some very detailed project management plans and adaptive management plans. And so we've completed all of that work and are routing all of that through the Open Ocean Trustee Implementation Group. So some of that will be published shortly. And then, this establishment of partnerships to support implementation plans is a major aspect of our planning work. We don't have the capacity in the federal family, the science agencies, to carry out these projects. We absolutely need support from academics and from really every sector, the NGO community, the commercial sort of vendor community. And so we've now got very important partnerships in place to support this work with groups like the National Marine Sanctuaries Foundation or the Smithsonian Institution, the Navy. I'll mention in a little more detail here shortly. And our one very important academic coalition is the Ocean Exploration Cooperative Institute. It's a NOAA cooperative institute made up of several universities, including University of Rhode Island as sort of the organizing group, and then Woods Hole Oceanographic Institute, University of Southern Mississippi, and others. And so these have been very important in helping us scope out some of this initial year's field work, and they will also support future years' work. So speaking of that initial year's field work, we've carried out a really ambitious scope of work in 2022, even as we were continuing to sort of wrap up that planning phase. And initially, we developed a sort of feasibility analysis that suggested we ought to be throwing about 200 days at sea in the field this year, and we ultimately ended up carrying out about 150, maybe 170 days at sea between 8 cruises, and those were carried out on a variety of different platforms. I'll describe a number of them here shortly. But the first of them was a multi-beam echo sounder survey from the ship that you see on screen is the NOAA ship Hassler, the Ferdinand Hassler. And this was actually resurveying that area known as the Pinnacles offshore of of Mississippi and Alabama on the edge of the continental shelf. And it was last surveyed in 2001 by USGS effort. And the result of that was a unified surface with a resolution of about 16 meters per pixel. So pretty hazy. And we've improved on that by at least fourfold. We now have maps over about 785 square miles at 2-meter resolution across that unified surface per pixel. Tremendous amount of data. You can, I believe this is all now uploaded into the National Centers for Environmental Information. You can go download this data set. It's being archived there. A huge volume of data, and even that though is not as fine resolution as what we hope to do in sites that we find that are particularly important. And I mentioned that synthetic aperture sonar work. That is what this torpedo style AUV, the autonomous underwater vehicle. This is a Remus 600 vehicle. It's got a 600-meter depth rating, and that large black panel on the side of the thing is the transducer for the sonar from that vehicle, and that's what produces that the synthetic aperture sonar that produces that 3-centimeter resolution mapping surface. So following on the Hassler cruise, we had 3 cruises that were focused on habitat assessment and evaluation objectives. We had the NOAA ship Pisces out between the end of June to the end of July. The NOAA ship Nancy Foster out through most of the month of August. And then the Point Sur out. This is a it's a LUMCON, Louisiana University Marine Consortium vessel that is housed at the University of Southern Mississippi. And that vessel was the platform for a cruise through most of the month of September, focused on sediment sampling for better characterization of sort of extending a time series of sediment sampling that was begun during the damage assessment and giving us a sort of basis for comparison with how things have changed over time at those sampling sites. What you see on the bottom right here is from our Deepwater cruise on the Nancy Foster. This is an image collected from the Odysseus remotely operated vehicle. Then we had 4 cruises that were really focused on objectives of the Coral Propagation Technique Development Project. We had the Point Sur out again for about 2 weeks at a time, I think, in May to June and in early October. And the research vessel Manta, which is the vessel that supports the Flower Garden Banks National Marine Sanctuary, leaving out of here in Galveston in July and September. And these cruises were multi-mission. You know, we did video transects to do habitat characterization, but most importantly, they were focused on sample collection for genetic connectivity analyses and for husbandry in our propagation labs. Okay, and here you see some of the samples that were brought back and are kept alive today in our propagation labs. We've got 213 colonies and fragments of 6 species in labs in Charleston, Gainesville, and Galveston. We have a National Ocean Service lab called the Hollings Marine Lab in Charleston. There's a USGS lab in Gainesville, and our fisheries and sanctuaries facilities here in Galveston. We saw spawning events in both 2021 and 2022 in the labs, so that's very exciting to be able to document. And we're expanding on these 3 federal labs to extend our network to aquarium partners, lab experiments with aquaria and academic partners, and outplanting corals in the field, getting substrate placement done in the field, and propagating the animals themselves, putting the animals that we've collected back out into the field to understand how they perform. Now that we've learned a little bit about their biology, we definitely are. We're testing techniques that will both propagate them based on reproduction in the lab or fragmentation in the lab, and in situ in the field, either propagation by fragmentation or sexual reproduction in the field with the availability of additional substrate. The Active Management and Protection Project, looking forward, is really focused on this science to management activity. So we've had a number of different entities identified that we intend to have regular sort of communication with, including Flower Garden Banks, Gulf of Mexico Fishery Management Council, Bureau of Ocean Energy Management, and the Gulf States Marine Fisheries Commission. In 2023, we think that we can get some of our threat reduction activities off the ground with sort of low-hanging fruit, as the rest of the projects did with the field work in 2022. There are lots of opportunities for sort of low-hanging fruit work in the marine debris removal and mooring buoy installation contexts in particular. Developing an education outreach plan that'll guide the rest of our implementation phase, and developing partnerships with public venues, aquaria in particular, for exhibits and displays. This is also perhaps a good opportunity to engage further with the History of Diving Museum. So here's my teaser for opportunities specifically related to diving. In 2023, we really have our first opportunity to get diving work integrated into our portfolio. And that's going to happen. Obviously, that can only happen in mesophotic depths. It can't happen any deeper than about 1,000 feet. And to that depth, most of that depth range is only going to be accessible by saturation diving. We have multi-stage decompression or rebreather technical diving opportunities in the shallower zone down to about 100 meters, I think. And so we are currently standing up some capacity to engage technical divers in a civilian corps and Navy divers that do saturation dive work for some of that deeper water work. And some of these images are that saturation diving facility that the Navy supports, both the control van at the bottom of the screen with all the gauges and knobs and whistles and so forth, and then the bell and the habitat in the image in the center of the screen. So this is a team of 26 guys, 6 of whom can be in the chamber at any one time, and they dive 3-man teams to 1,000 feet or less, and they can dive to those depths and stay saturated for up to a month. So it provides a really tremendous opportunity to do work that takes some time. The civilian corps can also get some really important work done. I think in particular, we're really focused on that group doing things like surveys of artificial substrates, sampling for coral biology or diversity, sampling for geology, deploying substrates for coral propagation. They can also do some mooring installation or fishing debris removal. But when we get into sort of OSHA working diver conditions, the qualifications become much more rigorous. So some opportunity, and we're definitely looking forward to having the divers engaged. We think we can get a lot more done, obviously, with the dexterity of the human hand relative to the manipulator arm on a remotely operated vehicle. So anyway, that's I think the majority of what I had to show you today, and I just want to throw up on screen a few contacts myself for the portfolio as a whole, and then for the active management project, we've the person who's really leading our science to management activity is Kelly Martin, and so her email address is there. And for education and outreach sort of opportunities or engagement, you know, if we wanted to develop something further with the museum, or if folks in the community down there have ideas for engagements with their schools or what have you, Sasha Francis is probably the best go-to for that kind of work. So I think I'll leave it with that and open the floor to questions if there are any. I see a few things in the chat. I don't know if these are questions or other.
Yeah, Julia's going through those. This stuff is fascinating. Where do you think your civilian technical divers will be tapped from? Like cave divers or colleges or what?
So the requirements for these divers are pretty rigorous. The person who is organizing this group for us is the dive safety officer at an aquarium here in Galveston, a guy named Jake Emmert, and he has a network of similarly qualified, you know, dive program managers from around the country, folks like California Academy of Sciences. There's a group over in North Carolina that's very involved in supporting work like this called Force Blue, I think is the name of that organization, is diving oriented.
Oh, they're great. Yeah.
Yeah. Okay. So that's, but again, these are rebreather dives or multi-stage decompression dives. So it's going to take a very highly qualified civilian diver to do this.
And will they be saturated for, what did you say, like a week or a month?
So the Navy saturation divers will saturate for multiple days at a time. The civilian divers really can only do bottom times of like 20 minutes to a half an hour. So the scope of their work is going to be much more limited. And then, you know, obviously to dive to depths of 300 feet, they have to decompress for quite some time.
Sure.
After that bottom time. But there are, you know, certainly if anyone is interested in getting involved in that sort of work, please do reach out, and I will put you in touch with Jake as he pulls this team together.
Great. Julia, do we have any questions in the chat?
I do not see any at this time. I think Kris was very thorough in his presentation.
Yeah, it's fascinating. You know, Kris, next year we're doing aquanauts to astronauts. And I know one of the comments was in the chat was, this is like going to space. And it is. It's just you have extreme pressure instead of lack of pressure. So you have to, I don't know if any of if you use any of the big 1 atmosphere suits to go to some of these depths, which is not as good as the human hand, but it still has that human factor involved.
Some of the Navy divers involved in the saturation dive team have told me about diving in those 1 atmosphere suits. We don't intend to use them in our portfolio, but those guys, they're brave, I'll say that, and even they are a little scared of those 1 atmosphere suits. One guy told me that he was in one which by the end of the dive he was up to his knees in water because it had so many leaks in it. He obviously survived the dive and told me he went back and did more, but I don't know if that would be me.
Right, right. And when you bring these specimens up and then grow the corals and are able to extend that up on the surface, what kind of transition do they need to go through to adapt to those environmental changes?
The corals themselves. So the biggest environmental factor that we find they absolutely have to have sort of maintained for them is temperature. Now these, to date in our labs, we've really only maintained mesophotic depth corals. We have not gone to the truly deep water species yet. And we intend to do that this year. And I will be very interested to learn about how differences in, gas partial pressures or pressure itself actually affect our ability to do anything at all, if possible, with corals from depths of a mile down. We're talking, the wellhead was at 1,450 meters or so, so truly close to a mile down. And the coral species that exist there, they're in fairly low densities to begin with, so we're very hesitant to do more damage than good by collecting much at all from the field where we don't find very dense aggregations. That's an important sort of part of our protocol, is identifying dense aggregations to sample from, so we're not significantly depopulating the local habitat. And that's going to be harder in deeper water because they naturally exist at lower densities. Largely because the nutrients and
Sure.
everything that are needed down there are much lower.
Wow. Okay. Well, this is all fascinating, and we hope that you can come back to the Keys when we're doing our aquanauts to astronauts and get some more comparisons between the deep water and the space. But it would be interesting to follow up with this. Yeah.
I do have one question. So the question is, what are the prospects for full recovery and over what time period?
Oh gosh, that is a great question. So the idea behind natural resource damage assessment restoration is to try to sort of bend the curve of recovery. So in a natural system, you would expect to see recovery over some extended period. In the deep water Gulf of Mexico, that would primarily be through the process of sedimentation, through hydrocarbons in the environment being buried to the point that they're not available for biology. They're not biologically available. That process in the northern Gulf of Mexico, I've heard a lot of different estimates about that, what that time frame will look like in the northern Gulf of Mexico. One advantage that the northern Gulf has is it's a very, very highly sedimenting system relative to, so back in the late 70s, there was a very large oil spill in the southern Gulf of Mexico called the Ishtak spill. And that resulted in oiling that was seen all the way up the Texas coast through the early 80s, mid 80s. I remember going to the beach as a kid and you had to bring your lighter fluid to wash your tar balls off your feet from the South Padre Island because of that oil spill. And I'm sure that did me a world of good. But the sedimentation rates in the southern Gulf are low. So the estimates of the rate at which that material that sank to the bottom around that oil spill were, I think, 140 years or something before it would have been buried outside of the range of biological availability. I saw similar estimates for the Northern Gulf for the Macondo well, the Deepwater Horizon rig, and those estimated a much shorter sort of time frame for recovery based on burial in the order of something like 50 years. But at the same time, our recent sediment cruise from back in September has documented that a great deal of that material that we were documenting in the damage assessment and continued this time series of documentation with our crews has shown that there's actually very little sedimentation on top of the hydrocarbons that are being pulled up in some of those sediment cores just around the wellhead. So that suggests, maybe that sedimentation effect is highly localized and just isn't as predominant in this. It's a very deep water area right around the wellhead. We might not be catching a lot of that Mississippi River outfall that is the source of a lot of that sedimentation right there locally. So that's a long-winded way of saying I think we have a lot to learn to be able to answer that question. And that's I'm speaking only to sediment communities with all of that, and I think that answer varies tremendously, again, based on the specific resource type that you're talking about. If you're talking about fish or marine mammals or sea turtles or a different sort of habitat, the answer might be very different again.
Okay, here's another question. What was the most interesting or fascinating deep sea coral species to you?
Oh gosh, they're all really fascinating. The one that's most interesting in our project context to me, and I mentioned some of the challenges that I think we're going to have trying to propagate it in the lab, is Paramaricia biscaya. And I don't know if I have any images in my slideshow of Paramaricia, but sort of pink colony, and really only exists in that very deep depth. And I think, learning about the biological processes, the life history, the reproduction modes, and so forth of these really deep water species, I think is a huge, will be a huge scientific win from our project.
Okay, this question's from Carla. She asks, do you think astronauts can learn from these divers, these aquanauts?
Well, I do. And in fact, we have a facility here in the Houston region where astronauts are doing just that. They're learning from divers in the neutral buoyancy lab right up the street from us in the Clear Lake area. I don't know if you guys have had presentations on that facility, but it's tremendous. The astronauts go through the whole process of doing the work that they're going to do in space in a low gravity environment of what used to be the largest swimming pool in the world. I'm not sure if it still holds that title, but certainly, I think it actually goes both ways. We can learn a lot from what NASA has learned in sending people into space in terms of what we are able to accomplish in the very challenging environment of the deep ocean. So yeah, I think plenty to learn all around.
We have another question actually from Dr. Sally. How soon after the spill was the damage evaluation done?
Oh, it was ongoing during the course of the spill. We began the damage assessment immediately. I was on scene as part of the damage assessment within 2 weeks as the spill was going on. Over the course of that 3 months before the well was capped, this was all the damage, the emergency response, the activity of trying to contain the well and respond to the immediate damage was all organized out of a facility, a BP training facility in Houma, Louisiana. Was initially set up for like 500 people. And at the height of the response and the damage assessment work, there were probably close to 3,500 people on that facility. They had to expand, everything, the cafeterias and restrooms and parking lots and everything about that facility to accommodate the response. And that work went on in the local area around. There were command centers set up in Houma and in Mobile for I'd say 6 months after the event began, and that work really only, damage assessment work continued through 2015 as we were working our way toward the settlement, because we, in this legal process, if you don't reach settlement, the trustee agencies are in a position where they have to prepare for the possibility of litigation. And so we have to continue to collect information that documents that damage over time. So it was very rigorous work for heavy emphasis in the field for at least 2 years, and sort of more sporadic field work with additional analysis for 3 years after that.
Wow. So on the picture that you're using on the slide, which is beautiful, by the way, what depth was this picture taken?
So this is a mesophotic depth habitat. I believe this was taken from the ROV Beagle aboard the Manta in one of those coral propagation cruises this summer. And I believe we're looking at Mauricia pendula on the right, and I forget what do we call those zigzags corals on the left. So the scientific name is escaping me, but that's the sort of common name.
Okay. It almost looks like it has little critters on top, the little white, shrimp critters on top.
So we frequently find squat lobsters and crinoids, sort of commensal sort of organisms associated with these big structure forming parts of the habitat. And that's all very important for us to document. If we understand what the community is supposed to look like in a reference area like this, it helps us understand what our target needs to be as we try to restore it in areas that might have been either were damaged or are, aren't suitable because of a lack of substrate or something like that. Another really interesting feature of this image is all of the sort of algal nodules, rhodoliths on the bottom, the crustose coralline algae on the surface of the rocks around the big structure forming corals. So
when one of Dr. Sally's observations is that, that at significant depths, the 1 atmosphere suits are good, but they're almost like an observation chamber, because you can't do a whole lot of, sensitive work with them. But what kind of damage did you come across as you were doing your assessments of these deep corals? What were the signs that was the most?
Oh gosh, I would have to point you to some of the literature about this, but the major sediment infaunal community, it's pretty clear when you see just mats of heavy oil on the bottom, you're going to dramatically affect that sediment infaunal community, and there's lots of documentation about how that community shifts with different levels of contamination by hydrocarbons or other contaminants, which also were present in the case of this spill because of the use of dispersants and the release of drilling muds and so forth, things like heavy metals. In long-term contaminant sites, you might also see things like PCBs and dioxins that really affect that sediment and faunal community. Other effects, there is a great paper on the effects to these deepwater corals. Specifically, I think it was Helen White is the primary author. I'll look for the citation and send it to you. That we're actually continuing a series of photo documentation of corals that were imaged during the damage assessment, where you can see, tissue sloughing off of the skeleton of the corals as a result of exposure to hydrocarbons. We saw, just depauperate areas void of some of the fish community that they might have had previously. So a wide range of effects from these exposures. Some of the really interesting, I would also obviously should point you to that programmatic damage assessment and restoration plan, because the chapter just ahead of the chapter on restoration is all about what was documented as damaged. So, there were toxicity studies on a wide range of fish, and really fascinating studies on the effects of exposure to hydrocarbons on things like larval fish heart development and or their swimming ability as they develop from larvae. So really, I think we learned a lot that we might never have even pursued, but for the spill, about some of these contaminant effects and toxicity effects.
Wow. Well, I just checked the chat. I don't think we have any more questions that you haven't addressed already. Thank you so much. This is a fascinating, different part of the ocean that a lot of us aren't exposed to and know about. And we appreciate your time. And actually, as a thank you, we will give you a 1-year membership to the History of Diving Museum, because we want you to come back. We want you and Carla to come back in town and visit us again, and dive the little shallow reefs we have over here just for fun. See Dr. Sally, spend some time. And
I love it.
Yeah,
I look forward to it. It's been a pleasure. I'm glad to be able to do it, and hopefully I can come back after a few years of this work and tell you more about what we've learned in the meantime.
Yes, that would be great. I wrote down your 2 contact people for your education outreach, and to see if we can put something together and to get an update. And for people who are watching this as a recording on Zoom, if you have any questions, put them in the chat box, because we do monitor our YouTube channel, and we'll get back with Kris and give you some updated answers. So thank you very much for your time. Thank you everybody for participating this evening, and we'll see everybody next month.
Thanks, y'all.
All right, thanks.